All right, kids, so Lewis acids and bases now, and just in case you couldn't read that Lewis, that is an E there with a negative sign for
Electron.
this is all about electrons, okay? So there's a lot of things that can be Lewis acids and bases, even more than Bronsted-Lowry, even more than Arrhenius. So this is an even broader definition of an acid and a base. So this requires a little bit of paying attention just to make sure we catch everything. So let's make sure we get it. So first, let's talk about what is a Lewis acid. Okay, a Lewis acid is any substance that accepts a pair of electrons.
Okay, so we've seen that acids are usually donors. Now we're saying acceptors. So pay attention to accepts.
Right. Bronsted-Lowry acids were proton donors. Lewis acids are electron acceptors.
Okay.
So if the Lewis acid is the electron pair acceptor, what is the Lewis base?
I would guess it's the electron pair donor.
Right, so we'll call that the electron pair donor. Now, I know you guys are just waiting to see this in action. So, I mean, why waste any more time, right? Why waste any more just sitting here talking about it? We could actually do an example.
Yeah, let's do it.
So let's do an example then. Great. Okay. This is a great example, and it lets me draw stuff too. So let's start with boron trifluoride plus a fluoride ion yields BF4 ion. Now, it may not be easy to look at it like this and say which one is donating the electrons and which one is accepting the electrons. So what I'm going to do is actually draw it out down here. So let's pretend that we have boron trifluoride, and don't forget your electron pairs around here.
Because fluorine has 7.
Fluorine has 7, so it has 3 lone pairs each here. So we have a trigonal planar geometry. So let's pretend we add this to a fluoride ion, which means it has an extra electron to complete that octet. So what's going to happen here is the only way for them to get a BF4 minus ion is that one of these pairs of electrons right here is going to have to be donated to this right here.
To make the bond, right? To
make the bond. So the result of that is you actually get a BF4 ion. I'll make my dots as quick as I can here. And the reason it's negative is because we have extra electron here on the boron. So with all that drawing there, who donated the electrons?
The fluorine.
The fluorine donated the electrons, making fluorine the Lewis
base.
Lewis base. And that makes this guy right here, boron trifluoride, the electron pair acceptor, making him the
acid.
Lewis acid. Acid accepted the electrons, base donated it. So one more example, because I know you guys are itching to see more examples. Let's talk about if we have hydrogen ion plus hydroxide ion makes water. Now, one thing you can look at here is, well, when these combine to make water, who has more electrons right now, hydrogen ion or hydroxide ion?
Who has more electrons? The hydroxide.
Yeah, hydroxide ion has more electrons. So does the hydrogen ion have any electrons?
Nope.
So who has to donate electrons here?
The hydroxide.
So the hydroxide ion is going to be your base, while the hydrogen ion is going to be your acid. So if we want to draw that out real quick, hydrogen ion here, and hydroxide ion is like here, has a little bit of a negative charge right here. So what's going to happen is this pair of electrons is going to be donated here, and you're going to end up with water. Okay, so that's pretty clear, right?
Yeah.
Awesome. I was really worried about being able to explain that, but we got through it.